Hello guys, good morning. Let me start with the NumPy basics first of all. So what is the NumPy? As we learned, right? So there are this basic libraries which are really important for the data manipulation kind of things. The basic libraries are, let me write them down. So first is numeric Python, and then there is pandas, and then there is scipy. Okay, these three are the basic libraries which are very important for you to learn. NumPy mostly deals with the basic. These two things are very related. The NumPy and Pandas, they are the core structure to handle the data. So you need to understand NumPy and Pandas when you're going to deal with the data. So that is really important. Scipy really comes when we are going to deal with the modeling part. When we go to deal with the models, the most of the libraries come from the scikit-learn and this scipy thing. Okay, those three things. So we will be covering for this 2 weeks now NumPy and the pandas. So let us start with the NumPy first. Okay, what is basically the NumPy? So let me directly go to. So as I told, right, NumPy basically stands for this numerical Python. The NumPy is foundational for it's mostly for the linear algebraic operations. So what happens with NumPy is we have a matrices kind of things. So what do I mean by matrices is we have a data kind of matrices. All the data files, right, that we deal with, they are all in this format. So there are the columns and the rows. So one will be a column and we have the rows. So this is how the data file is mostly. And to deal with this, so they are basically in the matrices form. Okay, these are called the matrices, and to deal with the matrices we need the linear algebra. NumPy is nothing but provides us the libraries to deal with the linear algebra. So we will see what are the different linear algebra operations the NumPy provides. Okay, there are mathematical and logical operators on array. Okay, so it's basically linear algebra, and the core object which is available, the basic library, the core library which is available in NumPy is called this ND array. We'll see how it works. Let me move on. As we say, right, the prerequisite is really the basic Python, which I guess already everyone is now good, so we can move on with the things. So what this NumPy array does is it deals with the multi-dimensional array. The table which I showed you, right, it is just a two-dimensional thing, but what NumPy allows is the multi-dimensional arrays. We will see like how the multi-dimensional arrays can be represented, but we will come to that. And there is this homogeneous collection of values. So what I mean by homogeneous is basically there is no dependency to the data types. There could be different data types the way we'll have the list. Okay, so it's basically collection of different data types. It's a homogeneous collection of values. The very important thing about NumPy is it's built on the base of C. The core libraries, right, which NumPy is using, they are built in the C. And if you know, C is the fastest language. It's very efficient language, so they have built it on top of the C. So that's why NumPy and Pandas are very fast and efficient, because they are built on top of C. Okay, so there are different lot of mathematical functions available through NumPy. Let us move on. Like what really happens. Let me move on first. Let us we try to import this NumPy using import NumPy as MP. I was just importing the matplotlib to just visualize few things, but in future we are going to have a complete session on MATLAB. So for now, don't worry about the MATLAB. Matplotlib, sorry, not MATLAB. Okay, so we have imported. So we have given the name of NP here. So we will be using NP as a reference. Okay, so how do we create the arrays in NumPy? So first thing that we have to do is we have to create a list. So once we have a normal list, such as we have defined a list L here. So this is nothing but a normal list that we have learned in a Python. So we have to use np.array and provide the argument as this list. Okay, if you see the structure, this is L, it is a list, and what we are doing is we are creating an object of np.array by providing it an argument L. So now we have an np array, so through which we can operate it basically based on the NumPy methods and functions which are available. So let me run this thing first. So if you see that the structure is a bit different, it says it's an array. and it's within the list. And when we see the type of it, let me just remove all this output first. So type is basically numpy.nd array, as I mentioned, right? So nd array is the basic object on which all these numpy arrays are built on. Okay, so there is this another thing. So numpy also provides a matrices kind of thing directly. What it does is, if you see, right, what's happening is, let me remove this thing first, separate out. So this is how the matrix is. This is an 3 by 2 matrix. So there are 3 rows and 2 columns. So this is a 3 by 2 matrix. Okay, and we are just converting it to an NumPy array here. So we just created an np dot matrix, and from matrix we just created an array. So this is just a few ways that we can use np dot array to create this your notebook different than what I yes. So yeah, so this is basically Jupyter Lab, Patrick, that I mentioned earlier to everyone. So this is Jupyter Lab, which is the newer version that Jupyter is providing. So there is this Jupyter Notebook and there is this Jupyter Lab. So Lab is basically completed ID kind of thing, which Jupyter is providing. So this is more of a recent beta and alpha versions they have started, and it's much better to use. I really like it because I see the files here, I see the running things here, there are different commands, and you can open multiple files in a single column here, single tabs here. So it's more efficient. Yes. So few things to remember. So what will happen is, few people may try to directly bad practices. Okay, so what is happening is, so here np.array is directly given a comma separated values, so it won't work in this case. So this is basically wrong, but we have to give the argument as a list. So that is how basically is the NumPy array. So let us move on to the typecasting. How do we define the different types within the data? So when I do this, if you see, right, what happens, what uh, not similar to the list. In list, what happens, we have each value as a separate entity. So when we create a list of L is equal to 1, 2, 3 dot 0. Okay, so in this case, if you see, right, what's happening is 1 is kept as an integer, 2 is kept as an integer, and 3 is kept as a float. So they don't change here, but in this case, what happened, we kept this as an integer, and float. And when we converted this to the NumPy array, what really happened is everyone got converted to the float. Okay, everyone got converted to the float. So we can control this behavior, but what happens is it will make everyone as a similar. The highest precedence data type is used, such as float is the highest type to the end, higher type to the end. Then string is a higher type to float. Okay, so those are the things. Then integer is a higher type to the boolean, so that will be the flow. If you want, I can just write like type precedence. What will happen is the first is like bool, then int, then float, and then string. Okay, so this is basically when some values are bool and some values are int. Most of them, all of them will be converted to int. And in the case of some are bool, some are int, and some are float, everyone will be converted to float. So those things to remember. And how do we control this behavior? So in this case, right, to the np.array thing, we can provide a data type which we want to set. Rather than making it a precedence based thing, we can explicitly specify like which type we want our np.array to be. Okay, so in this case, if you see, we say that convert everyone to float. In the second case, it is basically U. What this U means is it's an Unicode thing. So Unicode is type of string. So we are trying to convert this 123 to string. Then U2. This is just a special format that I just wanted to highlight here. What this basically does is it will limit the number of characters. So it will limit the number of characters to 2. It will crop, just keep 2 characters. And we have a complex type. So complex will just let us print it out. If you see, right, everyone got converted to float. This is having a single quote, so they are got converted to string type. Even this is string type, but I had 1, 2, 3, 4, 5 here, but only 2 are kept. Okay, because we set the data type to be u2. Okay, and then we have this complex. So there are these different types available that we can use for conversion. So basically, I have a list here of different data types that we can use, okay, to keep conversion things here. So let me now give you an real life kind of example. So what we have done here is there are these two data points. They are nothing but two rows of data. And what we have is the first one is name, second one is age, and the third one is salary. So everyone must have already thought like why are we giving everyone as a single data type? But in this case, what we are doing is to each value, right? We have a different data type here. So what's happening? Okay, let me run this thing first. And see, these are the two rows. So what happened is we have this. In this case, we have three values. First is the RAM, which is string. The second is basically the age you are telling, and the third is nothing but a salary thing. Okay, so these three are the values in each set here. These are the sets, and we have defined a two set. Then what we say is, then we are defining a data type which says the first value is nothing but a name of type U11. So 11 characters. Then the second is nothing but the age and which is of integer type. And the third is nothing but salary, and this is a float with the 4 decimals. Okay, so this is how we are trying to control the each columns here. If you can see, right, so these are nothing but a columns here. Okay, and these two are basically rows, and then ram 1 is a column, ram and sham is a column, 26 is a column of age, and this is really a column of salary. So I'll move on. So similarly, right, I have created a few more examples here. So in this case, what we have is nothing but again a 4 column data. This is not just a 4 column. This is basically a multi-dimensional data here. So this is just a dimensions part I'll come to. Let us see like how the dimensions work. Now the Subu F4 means basically we are just limiting it to the F is really float, and 4 just means that we are limiting it to 4 decimals, but we can just remove this thing and just keep F. Okay, it will give us the same data, so we don't need to keep this 11 and all. This is just to show you that we can limit the number of items using that format there. Let's do together thing. In the end, I have a real file that we can deal with. So there we can. So this is just an examples, guys. So once we have the real file, right, it will be completely different. There we will have a lot of things already set for us, but this is just an example we are trying to see here in this case. When we have the files and all, right, it will be completely different. Let us now understand like what happens when we have the multiple dimensions. So first thing that I would like to show is we have a row such as just now we saw, okay, where the columns are nothing but the name, age, and the salary. Okay, in this case what's happening is this is nothing but a, if we have this column, right, so this is nothing but a single dimensional array. I would say one dimensional. Okay, when we have multiple rows, okay, so in this case now what happened is we have a number of rows, we have a number of columns. This now becomes a two-dimensional array. Okay, so now what with the 3 dimensions? So let us assume there are different departments, okay, and each department is having their own list of employees. So in the case of departments, right, so we will have again a different set of employees, but that will be based on the department. So department is nothing but our third dimension. So if we say that this is a department here, so this will be a third dimension. And if we move on to one more dimension, say as a company, okay, if we have so we can't imagine those things in this case, but if we say that if we can just, what will happen is when we have this thing, When we have a same thing again copied, okay, at that time what will happen is that will be a company, and company will be our fourth dimension. So when we have a company, right, and the company, what will happen, this whole thing will repeat again for each company. So company will be our fourth dimension. So we can't imagine that thing, but you can visualize it as a multiple copies of this thing here. Okay, so that will be fourth. So we can have n number of dimensions. So there is no limit to the dimension. So above the company there could be another dimension which will have a bunch of companies inside it. That's how the dimensions really works. Okay, so let us define our own few dimensional things here. In the list we have defined these dimensions here, such as, and then let me create it a NumPy array. So this is how, this is a two-dimensional array here. So if you see, right, there is this number of rows and there is this number of columns. It's just that. So that's why it is a two-dimensional array. Okay. Then when we go inside, okay, so in this case what's happening, there are just predefined methods available in the NumPy array, which are really important. We have to understand these things. Okay. First thing, right? The first thing is basically the shape of the array. The shape is nothing but the dimensions of each dimension. What is the size? Let me again go back to this thing here. Let me create a one more thing here. So let me define that each value, because those are really important things with the each data, each array and the pandas whenever we go, right. So these are the really important parameters that we have to remember. So first is the shape. So shape basically means whichever is the dimension. Let me draw a three-dimensional array here, and in the third I just have, okay, so let me say this is a first dimension. This columns, right, the columns is nothing but the first dimension that we have. So columns are nothing but a data specific to each user, right? So each row, so that is basically the first dimension we have. When there is repetition of this each row, that will be called as a second dimension, and when we are trying to repeat this whole thing here, then that will become a third dimension. So in our case, shape is nothing but the length of shape is the number of dimensions. So the length of shape will be 3, and it will contain like what is the number of values in the first dimension. In our case, 1, 2, 3, 4. So this will be 4. In the second dimension, again we have 1, 2, 3, 4. Second dimension will have 4, and in the third dimension we have 2. Okay, this is nothing but the shape of the value, shape of the array. Okay, so in this case, if you see, right, the shape is nothing but 3 and 3, and it says the number of ndim. Ndim is the number of dimensions that we have. So ndim in this case is the type of the whole data type is basically int32. It could be complicated, and the size is basically the multiplication. So size is nothing but whatever the values in shape, right, it will just multiply. In this case, it is 3 multiplied by 3, 9, and with this case, right, it will be 4 multiplied by 4 multiplied by 2. That will be 16 multiplied by 2. The size will be 4 multiplied by 4 multiplied by 2 will be 32. Okay, so that's how the size will come. And 2 is department, 4 would be different company. Yes, so you just can imagine it in that way. 2 is not department. In this case is, first is basically the employee data. So this is basically each row of the data. The single row will have like the name of the employee, the age of the employee, the salary, and then this will have like multiple values of employees. This will be like a different department here. The third dimension will be department in this case. Yes, right. You got it. Okay, so let us move on. The shape basically means the number of values in each call each dimension, and the end dim basically says the number of dimensions. The length of shape will be the same as the end dim. Okay, that we have to remember. This thing is a bit complicated. It could become complicated as the type of the values may change. Okay, but this thing, the size basically means the multiplication of all values in the shape. Let us do the same example in this case here for a three-dimensional data. I've just got a dummy data here for 3 dimensions. Okay, let me print it out. How is this trying to represent this three-dimensional data? In our case, right, what we try to do is we stacked them in the back. So this was a basically first stack we had, and this was the second stack we had, right? So what Python is trying to do is keep the stacks in a separate line. If you see, this is like a 2 by 2. This is like a first and second dimensions, and over the third dimension. So for example, we had a departments, right? So what we can say in this case is this is the data related to the department 1. This is the data which is related to the department 2. Okay, this is how the dimensions are represented here. I guess everyone clear with this now. So I've just taken a small example, and so if you see, right, now there are 3 dimensions in NumPy, right? The way we saw it here, it's a bit different. What happened is I told you this thing as the opposite thing, but NumPy is storing this as a opposite way. The first will come the third dimension, the last dimension will come first, second will come the second dimension, and third will come the last dimension. Everyone be clear here. So this thing is the third dimension length, second dimension length, and the first dimension length. If you see, like, these are the 2 dimensions in the third dimension. Okay, 2 values in third dimension, 2. When we moved inside, there are 2 within that again, 2. And when we moved inside, there are 3. Let me print out for this thing here. Okay, so if you see now, in this case, the third dimension is having 2 values, and within that, it is having a 3 values, the second dimension, and the third dimension is the first dimension is also having the 3 values. Yeah, so let me first show you how is this array is being represented. Okay, so as Patrick asked, right, how is this bracket thing working? For the brackets, create this thing again. Let it be here, but let us create a list first. Okay, so basically when we have this blank list, and let me say 2 3 4, this is nothing but, so if you see, right, take it as a first dimension. So we have a 3 columns where the values are 2 3 4. But right now you can just imagine that this 2 3 4 is nothing but a employee data, such as the name of the employee, the age of the employee, and the this thing is nothing but the salary. Okay, just imagine it that way. We will take out the real example at the end, but just for the explanation part right now you can understand this thing. And so when we want to stack this as a multiple list, okay, what we will do is we can comma separate them. Let me just take some different values here. So what we have to do is we have to stack them within a list again. Okay, so this is nothing but list of list. So this is basically a list of list. Okay, and now to stack. So this happened is this is nothing but a 2 dimensional array now. If I take it L is equal to this, I will put L here. Okay, as you can see, right, what happened, the lists within got as a rows here. Okay, and the comma separated thing is making this thing as a list again. So these got become my columns now. So these are individual rows now, these are individual rows here. So this is a 2 dimensional array. So this is a 2 dimensional. So now when we move, so say these are my 3 employees in my department 1. So these are nothing but 3 employees, where each of this list will contain the detail for this employee. Okay, now I want to take the second department dimension. So I would say there are 3 departments now. Let me cover them inside a list again. Okay, so now when I'm trying to implement this thing, okay, so these are basically repeating, but you can see the gist of it. Like what's happening is these are nothing but the 3 departments. So this is my third dimension. Within that I have a second dimension, and the last we have the third dimension. Yes guys, yeah, I guess I had to start it with the blank thing, but I just moved on with the thing. So I guess now it's clear. So when we print the details for this list, right, the one we created right now, it will be 333, as you can see. Yes, so basically it is the third dimension will start first. The third dimension is having 3 values, and within that second dimension is having 3 values, and the third dimension is having 3 values. I guess this thing is already clear. Okay, so let me do it 4. So for the 4, right, I have to copy this thing. Okay, so this is a 4. But to make it 2, right, we have to do some things like, okay, for everyone's clearance, I'll do that. I'll just copy paste it later on. So what I'll do is, I'll take this. So we have to be really good with the parentheses. Okay, this thing is good. Okay, you got it? So I have a 4, 3, 2 dimensions now. Guys, everyone clear, right? This thing? This understanding of the shape and dimensions is really important. That's why I'm spending some time on this, because that is a really important thing. So let us move on to some cool methods which are available in NumPy. So these are really cool methods which are really handy, but we will see like how they become handy. So first thing, so let me explain you the things first. So this is NumPy zeros. So what will happen zeros? So let us first see what is this NumPy zeros. So zeros basically creates us. We have to give it a shape, and it will create an array for us which will just have zero values, and all the values will be zero. It won't have anything. It will just have zero values, but it will create it based on the shape we will give. Okay, as we already know what is shape now, we will see how we can use that. And then we have the ones, so it will just create a NumPy array with the shape where all the values are 1. It will create an empty. The values could be a bit random, but mostly it comes as a 1. I is nothing but a identity matrix. We will saw like what is really the identity matrix. We will come to that. So let us move on. So what we are doing here is np.zeros. We have to give a shape. So shape is nothing but a tuple, and we are saying 3 comma 4. 3 is my second dimension, 4 is my one dimension. So I guess everyone should be clear with this language now. The dimensions part where we have is the 3 is the second dimension, and the 4th is nothing but the first dimension. Because you understand, right? So what we say is this is basically first dimension for us. From where we start, from where we say that this is the first row, and the second dimension nothing but the duplication of that. So duplication basically means those same structure is followed. So we say 3 comma 4. So in this case we can also interpret it as there are 3 rows and the 4 columns. We can also interpret it as there are 3 rows and 4 columns. So this is nothing but x and y. So for you this is an x and y. No, don't go by x and y. This is just rows and columns. Okay, now let me move on to ones. The use of this, you must be thinking like what is the use of this? We will come to that, why we have to create these things, but they become really handy. So just right now see what is they are doing. So in this case again we have 2, 3, 4. So 2 is basically the last dimension, and within that we have the 3 dimensions and the 4 columns. We have an empty. So as I told, empty basically means it doesn't initialize anything. It mostly tries to keep it random, whatever is available in the memory. It will just initialize with that. But mostly it is 0. But don't go by 0. It will be like 0.0000234 something kind of things. But this is a bit of a random thing. So this is just an empty list. We don't have to be using this directly. We have to initialize the values to it. Now let me move on to the I. So this is called an identity matrix. Okay, this I is nothing but identity matrix. What happens is this is a square matrix. What do we mean by square? The number of rows and the number of columns will always be same. The number of dimensions, the shape in each dimension will be same, and what we have is ones in the diagonal. All the diagonal values will have 1. So that is what this identity matrix I is called. Yes, the empty reserves basically the memory. It just takes out the default values from the memory, but they are random. You don't have to be thinking them as a 0. So that is the only thing. It's just empty. You don't have to assume anything is there. You can initialize it by yourself. Yeah, but space is allocated to them. Let's move on. So there is this method which is a diag. So what this diag does is it will just extract the diagonal values for you. So what we had in our array, so from this array we want to take out the diagonal elements. If you see, right, 1 and 4 are the diagonal elements. So with the diag, we are just trying to extract those things. As I mentioned, right, so NumPy is mostly trying to deal with the linear algebra. So we have the data in the format of matrices, and we have to use the linear algebra to deal with this matrices. Okay, so that's why we are seeing most of the, if you remember the linear algebra from the class things, then you'd see that most of the things are from the linear algebra. So there are some special functions. So we already know about range. So what happening with the range? Range will give us a list basically of the values that we want. Okay. So there is this A range. A range is basically a part of a NumPy. It will create a range by the dimensions. Okay, so it is just creating a list similar to the range, but it is just in a NumPy array format. So just for the example, what we have is, so basically, right, the index of this, we will come to the indexing, but we will look at when we come to the indexes. I will give you this point again there. So range and a range, the nothing is different, but only thing is the a range will give you the output as a NumPy array. Okay, the structure is completely same. So as we know, we are giving it a start value, we are giving it a end value, and we are giving it a step size. Okay, as we can see, right, 10, 15, 20, 25. But when we see the form type of it, it will be the NumPy array. That is the only difference. Okay, and there is this one more method, which is a line space. What will happen? The difference between a range and line space is, this is a cool function. So what will happen? Okay, so we are trying to say that I have this number, these two numbers, and I want to equally create this many numbers between this range, and they should be equally distance. The distance between them should be equal, and I want 10 numbers. Okay, this is what it is doing. So what we're telling, we want the values between 1 and 100 included, and we want it to be divided into 10. If you can see, right, this is basically 1 here, not 0. So that's why you see these differences when we have the 10 values. So this is just to go with the what are the different functions available within this thing. And when we go to the examples, right, then we'll show how we are using it on a file. I know you all must are excited to see like how it is actually implemented on the data part. We will surely come to that, and that will be more exciting. The linspace, right? Let me make it 0. So it still tries to make like the 10 values. They are very close, but they are in the range of 11, 22, 33, 44. Okay, it's just creating the equal distance values in this case here. Okay. So just to give you an example, I imported a matplotlib. So this is nothing but a graph from the matplotlib. We have just created a line space of some equal distance, and we used it to print some pi functions, and that pi functions are given to the sin x, and the sin x will create as a graph structure here. This is just for example. Uh, if someone wants to go deep, they can, but otherwise it's completely fine. In the linear algebra space, when we have the matrices, we have a upper matrix and the lower matrix kind of thing. The triangular upper matrix, the triangular lower matrix. This is just an example of that. So what this says is triangular lower matrix. Okay, and it will try to extract the lower matrix. And we also have a upper matrix which will give us the upper matrix. This -1 are basically, this will just keep this diagonal here. So with that -1, we're just trying to remove that diagonal. And in this case also, it is again the diagonal with the 1. If we remove this 1, it will give us the diagonal also. So this is just a triangular up and triangular low. Sine plot. Okay. Yeah. So this is it. Let me print out the x. It's a lot of values. So what we have is, see what we have done, 0 to 2 pi. So np.pi is nothing but a pi value. What we did is 0 to pi 3.14. We created 100 values which are equidistance values within the 0 to pi. Okay, and then what we did is just npi.sin x. So sin x will create for every value it will create a sine point, and it will just, when you plot it, right, it will be sine struct. So we will see the power of NumPy. What happened, if you see, right, what happened is we created a single array x and we gave it x. Okay, and automatically what NumPy did is applied the sine function on each value of the x, and that was stored in f, and we plotted the f. Cool. Let us move on. The triangular up and triangular low. This is just to give you some examples on that. So printing array is again very similar to, I have the reshaping part, but let me do it here also again. We created a range. We created a 10, 9 values here. We already know about this shape. There is this method called as reshape. What this does is it just tries to change the shape of the array. This is a really cool function. What is happening here is basically we have here 9 values. leave that. So what we did is we took the 12 values here, and to 12, if you see, right, let me remove this thing first and then come to that. This is nothing but the 12 values. What I did is reshape 2 2 3. If you see, right, this array got converted to a 2 2 3 shape here. This is 2 2 and 3. This multiplication should always result into 12. That you have to be careful, otherwise it won't work out. Like if I say it as a 4, it will give me error because the shape reshape array of size 12 into the shape. Here the multiplication will change. The 8 4 multiplied by 4, it is going to the 16. If we make it 16, it will work out. Okay, so that's how the reshape really works. So we had a single array which was just a single dimensional, and from single dimension we tried to rearrange it and create a multi-dimensional array out of it. This is really important method. Similarly, 4 multiplied by 3, it's 12. So as I mentioned, right, we can split it into as many dimensions as possible, but we have to be sure of the multiplication should result into the length of the numbers. And this is just to show you the another example, and just to give you one more thing about the NumPy. So what I'm trying to do is I'm trying to print a 10,000 values. But if you see, right, NumPy is restricting me. It's just giving me few values from the start and few values from the end. It says it just try to save the memory for you. It doesn't allow you to see like lot of values because it will just choke up your notebook. You can change the settings as I have it here, threshold to none. The values could be anything. Patrick, as I say, right, this values could be anything, but a range doesn't work on the string. A range will only return you numbers. But if I have like S is A, B, C, and D, and NumPy.array and NumPy.s.reshape to 2, 2. Did you mean this? A range doesn't work with string. A range is just a function to give you a list of numeric values. Just a number of values from 0 to 1 to some length you specify, and it will just give you the number. A range we basically use for the examples in this case. Yes, a range can only take the numeric values, can return only numeric values. To give you an example, the a range is mostly used where we want to deal with the indexes. Okay, where we want to create a for loop, and for loop will have the indexes, and then we use the a range to create all those indexes. This is just an example like how we can create some random numbers within NumPy. Okay, so what happens is there is this np random rand numbers between 2 to 3. Okay, what this is trying to do is this is the shape of it, and uh, if you know, right, this is just a statistical thing like where we are trying to create a uniform distribution. Okay, where the distribution is completely uniform. Yes, this is a random numbers. These are basically based on the statistical measures like such as the random uh, that we will come later on, but such as the uniform distribution, we have the normal distribution. Those are the things. Yes, the rand n is the function which will generate a values between a with a standard deviation of 1 and the mean of 0. That's what we call the standard normal, where the mean is basically 1 and sorry, the mean is basically 0 and the standard deviation is 1. In this case, it is uniform distribution where the values will be equally distributed between the range of 0 to 1. Okay, and in this case, it is normally distributed or the standard normal distribution. Just don't think much about it. We will come to that. But this is just a way to, for the people who don't know about the statistics, you could just ignore it for now. But just try to see that rand is the important function where we can just create a uniformly distributed random numbers. And for the people who know about the normal distribution, the randn is the function to generate a random numbers between the with the values of mean 0 and standard deviation 1. Okay, if you want, right, for the people who are interested, plot this thing here. So this is the rand n where the values are basically from 0 and 1, but where we have to do is hist. For the people, right, who wanted to say this is basically the random normal distribution where you see that this is following a bell curve. Let me take the 1000 values to make it more clearer. So okay, this is basically a bell curve kind of thing where we have a mean 0 and the standard deviation will be 1. Similarly, if we are going to plot this thing, it will be uniformly distributed. There won't be, so it will be split over all the values. Okay, this is just a uniformly distributed. You just want to create a one random variable, you can just specify the one here, not a problem, right? It will just give you one value. Int form. So int, yes, so we have, I guess, rand int. Okay, so in this case, we have to specify it like a range. So it will create a value for you between 1 to 100 here. It will create a value for 1 to 100. Yes. Okay. So this is just a statistical probability feature where we have is what we did is take out, like as you mentioned, right? So we have this rand int where we have 1 to 100 and the 10 numbers. We want to extract 10 numbers. So as you say, you just wanted one number. For that case, it was 1. Okay. So uh, earlier we saw that, right? Just to extract the single value, we don't have to specify this. But when we want a multiple values, we can specify. It will create a random numbers between this range for us. This is just an example like where we are trying to extract continuously values between 1 to 100, and this is an example. So in this case, what's happening is we just have an example like a 20 sample drawn from a dice throw. So this is like having values between 1 to 6, such as a dice, and we took out a 20 samples in this case. Okay, so this is just a probability example for this. Guys, everyone clear till this thing? I guess this is interesting. Uh, but yeah, as we move on, right, it will be more helpful. But this is just to show the power of NumPy. What we are just looking at is different features available with the Python. Right now we are not connecting it with the real functions, but we will come to that. What are the basic operations available with the NumPy? So now let me see like what are the different basic operations available. So we created a NumPy 2 arrays here. So the cool feature with the NumPy is in basic Python, what we did is to add to list, we had to go through a for loop and then adding of the to list. But in this case, if you see, right, I created A and B. A is having 4 values, B is having 4 values. What I just have to do to add them element wise. So what we call is element wise arithmetic operations. So what will it will do is it will do this element to element wise operations here. So let me execute this thing. Say this 21, 32, 43, 54. So we just did a plus b and it created an addition of those two variables element wise. The shape should be similar. That we have to take care. The shape should be similar to make these operations. Okay, then we subtracted, we divided element wise, we did the multiplication element wise. See, but basic Python does not, so basic math type function would be faster than NumPy, correct? Yeah, so see the math type functions would be faster in NumPy, yes, because we are going to deal with a lot of bigger data. So that's why they have implemented in C and it's much efficient in this case. Basic Python doesn't, because in basic Python, right, we are not dealing with the bigger variables. Yeah, so this is a recursive function you are trying to create for a Fibonacci numbers. Right, takes a long time in C. I agree with that. So that's why the basic core Python is interpreted language, right? It's not compile language. So with compile language, what happens, everyone, is that code is compiled to a binary format, just close to a binary format, and after that, it will be very faster to execute. So this the operating system just take that binary and executes it. So there, it's very faster. With the C, it happens, but with Python, it is not the case. Python, it's doing this compilation at the live time. So as Patrick was mentioning, right? So other languages are fast because they are compiled languages. With compiled, it's just a benefit that they are compiled to a binary format where the operating system can execute them very faster. But with Python, it doesn't happen. With Python, the problem is it is interpreted. So it's just interpreted on a live time. As you can see, right, we are executing a single statements. It's getting compiled on the fly and it's getting executed. So that's why it's a bit slow. So in NumPy, what happens is the core functions, right, they're already built with the C. So let us move on. So this is basically the element wise operations. So let us see the different kinds. So we can also do scalar level operations. So there are two kinds of operations. The first is where we have the shape similar. For A and B, the shape should be similar. And in the second part, we have a scalar. With scalar, what will happen is we just have a single value, and that we are trying to do the operation with that single value to every element. So we are trying to raise to 2 for every value in B. Okay, this is how the format is. We are trying to apply this operation and every value will get the operation applied. Similarly for multiply, we already saw that. And okay, so this is one special thing that we will see, the Boolean operations. Okay, when we do this right, less than 35, what's happening is it's trying to create a evaluation. So this thing is really helpful. But guys, I'll come to it later, like how we can use it. But just see that doing some logical operators on the variables will give you a true false feature. The shape will be very similar to the actual NumPy array. The shape is very similar, but just it will have a Boolean values. So this Boolean values, how useful, we will come to it. So let me move on to the matrices now. So similarly, what we are going to do is we just added the matrices. The shape of the A and B is completely similar, 2 by 2, 2 by 2. When we do the add, right, it gives us the value. Okay, this element wise addition works here. Yeah, so it will give you an error. Yeah, be less than 15, right? I'll less than 35, I'll come to that again, but just remember right now what it is doing is just giving us a boolean values where the value is less than 35. It is just comparing every value of A. If it is less than 35 or not, wherever it is less than 35, it will say true. Where it is not, it will say false. What it's saying is operands could not broadcast together with the shapes 3 2 and 2 2. So that's what it is. So you can't do with the different shapes. The shape should be similar. Yes. So the power of it is, yeah. So everyone, I guess, it got it. So we need the shape to be similar. And the other thing is basically we can do the scalar level addition. So it will just add 10 to every value. Okay, that's how it is. But I'll keep this as this so that when you see it, you will remember this. So we saw this thing, and then we saw this. Yes, I guess I actually changed the values. So let me run it again. So this is element-wise multiplication. Now let me come to what is really a matrices multiplication. If everyone remembers, so matrices multiplication is not same as. Sorry for my handwriting, guys. So in matrices, what happens with the multiplication is, so first this is multiplied with this. So we are not going into matrix multiplication much, but this thing, right, this will be very helpful when we move on with the deep learning and all part, right? So you have to remember like how the matrix multiplication really works. Okay, let me take it as 4 and 5. I'll take it as 6 7. So now let us move in with the multiplication thing. So as you already saw, right, so let me do this. 2 multiply by 6 plus 3 multiplied by 7. We multiplied this and this element wise, but this is row wise and this is column wise. So again 2 and 3, 4 and 5. 2 multiplied by 4 plus 3 multiplied by 5 and 1 multiplied by 6 plus 1 multiplied by 4, 1 multiplied by 4 plus 4 multiplied by 5. Okay, this is what. So now the new matrix will be basically uh, 12, 12 plus this is 21, 33. Okay, so this is 12, 12 plus 21, 33. This is 8, 8 and 35, 43. So this is 6 and 4, 10. And this is 4 and 20, 24. Okay, this will be your new matrix after the matrix multiplication. Okay, what we saw in the row 2, in 2 row, I think it is 1 multiplied by 7. Sorry, yeah, I guess it's 1 multiplied by 7, right? Thank you. So let me make it 1 multiplied by 7, and it will be 6 and 7. Let me erase it. So this is 4 multiplied by 7. Yeah, thank you very much. So this is 28 multiplied by 6 is 24 again. This is, sorry, 28 plus 6 is 32. 34. Yeah, we can't take letters, right? Because we have to do the multiplication matrix because the number should be there always. But everyone, is it clear? This matrix multiplication. See what is happening is this thing is multiplied with this thing. This thing is multiplied again with this thing. This and this and this. If we have like more rows, right? So just let me be clear that when we have this 2 multiplied by 2 and this is 2 multiplied by 2, these two should be always similar. Okay, these two should be always similar to make it matrix multiplication in matrices multiplication, and your output will be this and this. So to give you an example, when we have 3 multiplied by 2 and 2 multiplied by 4 matrices, this 2 and 2 is similar. The output you will have is 3 and 4. Okay, we will see that when we will do the implementation of this case. Okay, so let us do one implementation of the same numbers that we have there. Okay, let me do the same numbers. A is equal to np dot array, and what we have is 2314. P is equal to np dot array. We have 6475, 64 and 7 comma 5. Okay, this is what the matrix is: 2314, 6475, and let us do. So basically, to do this operation, right, what we have is a dot b. So as we saw, right, 33, 43, I'm wrong here. So yes, this is 8 and 3, 5 is 15. Right, it's 23. I got it wrong. So that is 23, 34 and 24. As everyone clear, right? So this is what this matrix multiplication does. So see what happens with the vectors, right? So when you have these kind of things here. So this is also the length of 5, 6. So when we do the dot product of this two, it will give you a single number. Okay, when we have these kind of vectors, right? So when we do the multiplication of this and this, it will be a summation of this multiplied by this plus this multiplied by this. So this is how the dot product is for the vectors kind of thing. When we have this one dimension array, then it will be that way. Yeah, it's a 2D. Yeah, as Patrick is mentioning, it's similar to that. Okay, so I guess it's clear. Then I'll move on. So I just wanted to say that I just wanted to also give you an example like what will happen when we have different shapes of array. So I just wanted to clear this thing now because it will be helpful for you when we will have it again similarly when we do the deep learning. So it will make you things very easier at that time also again. Okay, so there, because in TensorFlow we mostly deal with the, if you know everyone TensorFlow, don't worry, but this is just a library to deal with the deep learning. There we have matrices and we do the matrices multiplication there. So this thing will be really helpful for you there. Because here I'm putting these random values. Don't worry much about it. So let me make it C and D. C dot. This is basically yes. As I told you, right? When we have the shape. So in this case, the shape is nothing but this is 3 multiplied by 2 and 2 multiplied by 2. So as I told in this case here, the thing we had is 3 multiplied by 2 and 2 multiplied by 2. In this case, 2 and 2 should be similar to make the matrix multiplication work, and the output will be 3 multiplied by 2. So in this case, we have a matrix which is 3 multiplied by 2. Yeah, so it's better to do sometimes with the hand. And after that, if you know the concept right, then you can do the Python version for automation of the things. So dot and the multiplication. Multiplication is the element wise thing, and the method there is dot to do the linear algebraic multiplication. Let me just cut this thing and paste above. Just a minute. Like np dot dot is just having a different structure. So it is just giving is np dot dot is a method to which we are giving a two more than two or two matrices, and this is the format where we have like element dot into the bracket element. These both are nothing but similar. Okay, both are doing the same thing. Yeah, guys, for the ones who are good with the maths, right? For them, they can understand now. But Patrick, I guess everyone won't for now. So in this case, let me add. So now, the dimensions are completely changed. It is 3 multiplied by 2, and no, it's still 2. What I have to do is to add this thing again. Okay, so now the dimensions are changed. So now let me do C dot see the shapes 3 comma 2 and 3 comma 3 not aligned. It's saying these 2 and these 3 are not equal. The dimension 1 and dimension 0 from these things are not equal. It's already saying this thing. So that is the rule in this case. It's
Hello,
still
Rishi.
Yeah, hello.
Hey, I just had a quick question.
Sure,
Uh,
go on.
I was trying to do this. I was trying to split. I was trying to use the split function by combining OR function. It doesn't work. I'll just give you an example.
Sure. Yeah, give
Mm.
just example.
So this one that I just typed. So
Okay,
if
with
I want
this
to
won't work.
split a string either on the spaces of space or on comma, it doesn't the OR function doesn't work in
Yeah.
this.
Or won't work. You have to again use the split on top of it.
So say I have an input which is a combination of spaces and comma, input of strings which is a combination of spaces and comma, and I want to store it in a list form.
Yes.
So
I'm
I
going
want
with
to
you.
I have to
Yeah.
do the split twice, is it?
Right. You have to do the split twice at that case.
But in that case, it'll store different variables, right? It'll
No.
store
I'll show you.
store
See, if I have L is equal to some string which is like A comma B comma space C and then again D space E. Okay, this is how you want it, right?
right.
And then if I say split first with comma, then I would say then split
Oh, okay,
with
okay, understood, understood,
yeah.
understood,
So then when we run it,
understood.
right? List object has no split. So uh, okay, yeah, there's still a problem. Wait,
No,
it
L has to be a list, right?
no, it's still a problem because it's returning a list to you, so it won't work. My logic is wrong here. There is, I guess, a way to provide a multiple. So for that, we have to go with the regular expression. That will be a bit more of a thing. Okay, so we just have to let us do it. It won't work directly with the normal thing, but there is this regular expression kind of things.
Okay.
So, do you know about regular expression?
No, I don't know about regular expression.
Yeah. So, just to solve your problem, I'm just giving you. So, these are so
Understood.
regular expression provides basically some see this thing.
Got it, got it.
Got it right. So, it's just a bit
Yeah.
more advanced thing. So, regular expression gives you some splitting formats where you can parse the strings and all. But for
Okay.
now, you can use this thing.
Understood.
Understood, right?
Yeah.
Okay.
Patrick, I'm just trying to split a string which is separated either by a space or a comma into
Okay.
individual characters.
Individual characters. But you got it right now that you can do it that way.
Yeah, yeah, yeah. I got it. I got it.
So
Just Patrick was asking what we were trying to do.
okay, yes. For Subbu random is basically what we do is we try to create some. Sometimes, right, we need different random variables to deal with the things. So in this case, what's happening is these random numbers basically generate a list of numbers for us, which are random but have some unique features. Let me just show you. So in this case, right, what's happening is we just leave this thing. So you can just go with this thing. Yes. So this thing here. So this is just to give you an example, like what will happen. We want to generate a random dices. the users are playing a dice and the dices are fixed between 1 to 6. Okay, the numbers are between 1 to 6, and we want to see, like, we want to extract few numbers which simulate this behavior. Okay, so we just say that give us a random 20 variables. So each time it will try to extract a random number from this range here. Okay, so we can simulate with this example the dices thing. So that's how the random variable works. We just try to extract a random number of values with some unique features. So in this case, it is just a numbers between 1 to 6. So just to clear the, maybe I have not gone deep into like how the element wise is working. And so with element wise, right? So we have this matrix 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is like 10, 11, 12, 13, 14, 15, 16, 17, 18. So guys, so element wise operations are nothing but we have plus, minus, multiply, divide. Okay, these are the element wise. Even we have the mod. So what will happen when we try to do these operations on these things is it will do the element wise operation. So what I mean by element is one. So when we do the summing, so one will be added with 10, 2 will be added with 11, 3 will be added with 12, 4 will be with 13. So this it will continue. So we can do each of this operations. But the only thing we have to remember is shape of A should be equal to shape of B. Otherwise, it will give us an error. So these two shapes should be similar. And on the other hand, we have this dot, which is called basically a multiplication in the linear algebra. Okay, so that is completely different than what we saw in the previous thing. So I just wanted to be clear with these two things here. Okay, so if everyone is clear, I'll move. So we saw like how the reshape is working. Okay, and okay. So there are these different methods. Okay, what these methods are called as universal methods. So each NumPy array will have this number, this different method. We will saw like what are the different methods available. But what we can do is this will return a single value numbers in this case. So it will return a sum of whole matrix, the minimum of the matrix, A dot matrix maximum, the mean and the standard deviation. And there are few more available. And just let me tell you this thing here. So there is this feature of access. Okay, what this access does is, let me run it first. A, let me tell you, this A0, right? Zero access zero is nothing but a dimension here. So access is the dimension. What we are telling, zeroth dimension. So in this case, zero dimension is this here. Okay, and it's trying to create the sum over zero dimension. So if you see 12, 15, 18, and this is 21. So when we are giving it axis 0, it's trying to make it based on the axis, the dimension 0. When we do the shape, right, this is the dimension 0 and this is the 3, and this is the dimension that it's trying to work on. And when we do the axis equal to 1, okay, it's now working it on the second one. So this is trying to do it like this. If you see 6, 22 and 38. Okay, everyone, this thing is very important. So when we have multiple dimensions, right, so when we have 3 dimensions, then we can have the axis 2 also. Similarly, we can take, so every of this function, this is called the universal functions, and each universal function has this axis, and it helps us like to define at which axis we want. We want a whole array, we want a single axis where we want to deal with. So there is this cumulative sum. So this is trying to deal with the axis 1, and it will do is to take the cumulative sum of it here. Okay, guys, axis 0, axis 1, axis 0 starts with at this point. It's trying to make the additions. Axis 1 at this point, it's making the trying to make the operations. Yes. So in our above case, right, this thing only, the axis 0 is basically the dimension 1. So this is axis 0. Let me draw it here. So for our example, what we have is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, let me take it out. What we say is, in this case, right, axis 0. In this case, axis 0, when we're trying to do the sum over axis 0, this is working it like this. Okay, it's taking the sum from this point of view. So we know, right, this is the first dimension for us. When we do the shape, we get these as a first dimension and we get these as a second dimension. So when we do the axis 0, we are getting it in this direction. And when we do the axis 1, the operations will be performed in this direction. Yeah, you can say that, but with the more number of dimensions, right, it could get bit complicated as we have more number of dimensions. So in this case, if we had 3 dimensions, right, that will be a completely different picture. So we will see that also. We will see that in our example that we are going to do, right? But if you understand it, here it's okay. So let me move on. So basically, these are the universal functions. It was a saying, right? These are basically universal functions. There are a whole lot of universal functions available, which can give you a single output or a different output based on it. Okay, there is this cumulative sum, cumulative product, cross product, differences, dot, floor, inner, inverse, maximum, and this is exponent here. Yeah, in this case, it won't work. Square root is here, and there is this argmax. What this thing does is, okay, we want to find the maximum, but we want to find the argument. Okay, this gives us the argument of the maximum function. Okay, 0, 0, 0. It says from axis 1 it is 0, 0, 0, and at axis 1 it is 2, 0, 2, and AS. So let me move on like how we do the indexing, slicing, and iterating. So this is what we have similar to. So let me take this lint space. Okay, for the single dimensional part, we can do the indexing as we do for the list. It's just almost equal to list. We can make changes to this using list from the value 0 to 6 with the step size of 2. Change values to 100. So if you see, with every step size of 2, value has been changed to 100. So let us now see how we check for the multi-dimensional part. So this is cool here. So now again, what will happen is, so for the, see, we have to look it from the shape part. When I do the shape, a dot shape. So first is basically 5. This is nothing but a rows. 4, which is nothing but a columns. Okay. So shape as per the shape. So this is basically going from between this 5 to basically rows, and this is going for the column. So we want to take 2 to 4 rows. So 2 will be here and 4 will be here. And out of this, we just want 1, 2, 3. So it will be 1 and 2. So 1 and 2 will be this and this. So let me execute this. 9, 13, 10, 14. So this is from 2 to 4. 2 to 4 means 2 and 3 only will come. 4 will get skipped. So it will only have this rows. And then we have 1 and 3 in the columns. So we can again move to this. We can say that. So if we want to extract, right? If we want to extract this part, 5, 6, and 10. Let me change the color. So what we can do is, so first if we compare it by the row wise, so row wise we have indexes 1, 2, 1 colon 3, comma, okay, 0, 1, 2, 3. We don't have 3, but we have to mention 3 as it will get skipped. And in this case, we again have 0, 1, 2, 3. But if we want to take out just this part, okay, so it will be 0 to 2 and 1 to 3. This indexing part, is it confusing, or maybe at first time you will feel like what is happening, but if you see, right, this is nothing but we are trying to select the, yes, so 0, right, basically we are trying to go this row wise here. Okay, so row wise what we are trying to say is 0, 1, 2, but 2 will get skipped, so it is 0 and 1, but we have to give it 2. Then in this case it is 1, 2, 3. Yes, the index value starts from 0, 0. Yes, Patrick, so this will start at 0 comma 0. We'll just keep some bigger one. So 1, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so first of all, let us see like how this indexes are working here. So indexes are basically, so if we go by this, right, this is 0, 1, 2, 0, 1, 2, 3, 3, and in this case it is 0, 1, 2. Okay, if now we want to extract this part here, okay, what do you say? How do you access the row first? If we just want to access the row, you let me know what would be the indexes. 0, 2, right? So I'm just selecting these two rows here. Patrick, what happens is we give it 0 to 2, but the last one is ignored. So it will just select it for 0 to 1. Columns, what would you say? It is just similar to the list. Think it as the list, and then how do you select these two here? So this starts from 1, but will go till 3, but 3 is excluded, so it will only select 1 and 2. So, but as per the indexes, we say 1, 2, 3. Patrick, you are confused or you got this thing? See what happens when we have the list, right? When we have a list 1, 2, 3, 4, 4, 5, and 6, and we want to select these two values, and we have the indexes 0, 1, 2, 3, 4, 5. We say if we want to select 3, 4, and 5, we say 2 to 5. If L is equal to this, we say L 2 to 5. Got it, right? Yeah, so that's how we select this matrices in this case. So this is what happening in this case. When we say, right, 2 to 4, we say 2 to 4, it will just select 2 and 3. So in this case 9 and 13 are the rows. This got selected. And when we are telling 1 and 3, so this will be the 1 and 2. So 3 will got skipped. This is how we try to access this thing. Even we just want a single element, we just have to provide the row and column. Okay, in this case 2 and 3. So this is 2 and this is 3. So we got a single element. Okay, and similarly we can select like, okay, 0 to 3 are the rows, and we want a first column. So it is 1, 5, 9. Okay, 0 to 3 is the rows that we want, and we say the first column, and so it gives us a 1, 5, 9. If we want to select a whole thing, like either be it a row or be it a column, but if we want to select a whole thing, we just have to keep it like this colon here. So what it will do is it will select all the rows. It will select all the rows, and we just say that we want a first column. We just say all the rows, but the column is 1. So 1, 5, 9, 13, and 17. That's what we got here. Again, let us move like, so in this case what we are telling is 1 and 3. So 1 and 3 will start with 1, 2, and we want all the columns in this case. So if you see, right, 4, 5, 6, 7, 8, 9, 10, 11. So this minus 1 is trying to take out the last row. And if I say again the minus 1, it is giving me a last value. There is this one more thing which says, similar to this, right, there is this 3 dots which says select everything. So just same to what it does mean. There is this two ways. So there is this 3 dimensions. Tell me if I want to access an element like this part here, 21, 22, 26, 27. What would I do? How do I slice it? Please think, I have a dimension 3, 3, 5. And I want to slice this 21, 22, 26, 27. So how do I do it? In this case, you have to remember that we have 3 dimensions. So we will have 3 slices. Yes, so you have to also take care of the 2, 2, 1, 3, 1, 3, 2. But why are we taking 2, 2 here? Okay, so let me go step by step. Okay, first is the third dimension we will start with. So in our case, this is the first dimension, and this dimension basically means this department kind of thing that we have as example. If I want to select, first of all, this block, I just want to select this block. So for this 0, 1, 2 is the index. Can I access it just with saying 1? Okay, I got this. I got the first indexing part where I selected the dimension that I want. Now I say comma. So now within this, I have to select 21, 22, 26, 27. Right, so I have to select the rows first, and in this case the rows are from 1 to, we can also use this. Okay, if we can select all the rows below that. We want everything below the 1, we can select this thing, and we say 1, 2, 3. For the people who gave me 1, 2, 3 here, that is also right. Yeah, 1313 was right, but just this dimension that we wanted to select it, so everyone gave 1313. Just to select this thing, we have to do either 1 2, could give it 1 2, or we can directly say it 1, because it will just select the second one, but we can make it simple in this way. In our case, we had everything below the second row, can keep it this way. Everyone clear with this example? So let us try to take this 33, 34, 38, 39. Okay, this 33, 34, 38, 39. So start with the first dimension. So you selected 3, but we start with 0, right? Right. So there you start with the 2. Okay, so there we start with the 2 first, which will give us the third dimension, this third array here. And out of that, so 2 comma, yes. So you are there, but not 2 colon, it will be 3 colon. So what will happen is, comma, 0, 1, 2, 3. So this is 3, right? So after 3, everything. So 3 colon. So what happened in this case? Okay, sorry. So this is not 3 basically. This is 0 and 3. 0, 2. Okay, so the few important things to remember, right? So this method, the access part is the important part, and after that the indexing thing. So these two are the really important thing to deal with the data. Okay, let me see with the iterating part. So guys, we saw the indexing now. So similarly, what we have is, let us go step by step in this case. So let me run this thing. So what is happening is, we say for access in B, let me remove this thing, just print access 1. Okay, so what we are trying to do is, so now see, we had 3 dimensions. So when we are doing the first looping, right, we get individual the third dimension data. Okay, so we are dealing with this third dimension data. If we go a for loop inside and say for access 2 and access 1, let me remove this print, keep this thing, print. So now what is happening? We are trying to get the individual rows here. Okay, when we are iterating, we are getting the individual rows within the second for loop. And if we do the third for loop, as you know, we will get the individual elements. Okay, that will be a very big thing, but just try to see that if we do the third axis, right, third axis will give us individual elements. So this b dot shape. So based on this, right, when we go to the first loop, we will have 3 iterations. When we go into the second loop, we will again have 3 iterations each. And when we go into the again third loop, we will have 5 iterations each for 5 elements. If that's how we access it. So even we can access it by say for access 1 and range of this, we can take it 3 right now, rent. So rather than access 1, I'll say I. This is the other way that we try to access it. Access 1 is basically, so in this case, go think it as access 0. Okay, and this will be your rows. Yeah, so this will be access 0. Okay, let me clear the confusion. This will be access 1. So access 0 will be your, so in third dimension, right? Again, with the 3 dimension, it's no rows and columns kind of thing now. So when we are with this 3-dimension data, right, we are not limited to the rows and columns now. So we have this third dimension, which we say such as the department, just for the example that we have. And within that, if you see, there could be a rows and columns. But this is a higher level rows. Within that, there are lower level rows, and then you have the columns. Please try to see that this is just not limited to the rows and columns in this case. It is there, but the first axis, right, the axis 0, which is a bigger dimension. Within that, we have the rows and columns. See, what I would suggest is I have a file here. So this file I have got it from. So this things, right, the part which we are left here right now. Let me just cover a few things, then we will come to the example. So guys, this thing, right, that we're trying to see here, we will get it more when we go with this file. So the file, right, I have a Bitcoin data. So I have a Bitcoin data in the file where we have a Bitcoin data for 28 days, and there are 4 Bitcoins, and each one is having a 28 days of data. We'll deal with that file, okay? But for now, just try to see this as there are 3 departments. Within that, there are 3 employees, and each employee has a 5 attributes such as name, age, gender, his department ID, such as kind of things. So see this example is in that way. So this is departments. Just don't take it as a rows and columns in this case. Try to think it in a more example point of view where we have the departments, individual employees. Within each department there are 3 employees, and each employee is having the 5 attributes. Okay, so when we are trying to access this first loop, right, we are trying to access the department data. So in this case what we are doing is, let me say print department I. Okay, this is how it is. So what we did is we got to the department 0, this is the data. Department 1, this is the data. Department 3, this is the data. We are trying to access it with the first index. Okay, now let me take out a second thing here. For j in range 3. I won't dynamize it and variabilize it right now, but just try to get a gist of it. Now what will happen is we say this is department I, okay, and print employee J. And what we have to do is we have I and then we have to see the J. Okay, so now see what is happening in this case. So we went into the department 0, then within the for loop, right, I and J, if you see, we got to employee 0, we got to employee 1, we got to employee 2. Then we went into the department 1, employee 0, employee 1, and employee 2. Let me say I want to take out a maximum value from each department. So b dot max access equal to 0. So this access 0 will work on the department level for each employee. So in this case, what is happening is at the department level, it is trying to take out for the each employee. See, it is doing is for the each value, it's trying to take the max. It is doing the element wise thing. So as we saw, right, it will move in this format first. So axis 0, it is trying to take the maximum values from this here. Slash t in print statement. Okay. Yeah, but for this case, yeah, but we can get a gist of it here. Guys, I know it a bit confusing. There are a lot of new things in this case for you. But once we go through it, right, you will get to it. Don't worry and don't panic about it. But yeah, see in this case, what's happening is b.max axis 0 is trying to take out the values from each dimensions within. Okay, when we have the axis 1, now what it's doing is it will be taking it on the this part here. So 10, 25, 40. This is the second dimension now. This is nothing but a B1, B0, B1, B2 when we did print out in the departments. So axis 0 is giving us a maximum employee from the each department. And when we do the axis 1, We are getting within each department which are the employees who are bigger, as it is axis 1. When we do the 2, so it's now a bit different case. So axis 2 we know, right? That's the uh, features of the employee, each employee features. So in this case, it is trying to take the maximum from each features here. So in this case, it is 4, 9, 14, 19, 24, 29, 34, 39, 44. Okay, so let's move on. Okay, let me do. So B had a shape, right? So we had a reshape to the B. Let us move on. So we can use this flat function to convert it back to, this is the way. So what flat is doing is basically it's just trying to convert your whole reshape of the data to a simple list. We came to the shape. Okay, we saw the flat. Flat is nothing but what it's trying to do is it's just converting all your shape of the data to a single list again. Okay, that's what the flat is. It's just giving it a flat structure. Okay, so this is just nothing but we have this shape similar to flat. Flat is giving you iterator, and there is this ravel method. It will return the list. Okay, it's returning the list. But what flat do is flat is basically giving us the iterator through which we can iterate it using the for loop. So we can ravel it and we can reshape it. That is the feature that we have it. Okay, we can ravel it to some different shape and again give it a new shape to it. Okay, and there is this transpose method. Transpose will do is it will just try to create a transpose. So transpose is nothing but a, let me print the A first so that you will get it. 0453. It got to the, so rows will become columns and columns will become rows. So that's how the transpose works. There is this again a resize method. Resize, what it will do is it will change the actual array. In reshape, what happened is it was not changing the A. When we did the reshape, it just returned as a new array which had that shape, but it won't change the actual array. So there is this resize method. This resize will actually change that array. Okay, it will change the A itself. The resize and reshape. What reshape does, it will just return you a list. It will return you a new array with the given shape, and with the resize, it will change the existing array that you are giving. So if you now check the A dot shape, it will be 2 comma 6. Okay, so there is this minus one thing. So let me tell you what this does. So what this minus one is helping is when we want to say that I know what are the number of columns that I want, but I don't know what is the number of rows I want. You decide on it, but I'll just want two rows in this case. For in this case, right? I'm telling I just want two rows. You decide on whatever number of the columns. Okay. So what it will do, it will just, the 12 is the size. So it will divide the 12 by 2 and will create the columns as 6 automatically and will give you the two rows. Say why would you change the columns? Yes, this shape, right? The shape of the things you mentioned, right? Yeah, this shape changing is really helpful, and I'll surely give you the examples. When resizing, does it check if the final size is same as the original size? Yeah, it absolutely checks the shape doesn't match, right? It will give you an error. So if I say 7, it will give me an error. So this is how the file structure is. So what I have is there is this date and there is this currency. So currency is basically I have 4 cryptocurrencies. So the currency column contains the name of this currencies. There is this date column, and for every cryptocurrency is having a 28 days of data. So 28 days is nothing but a 4 weeks of data. And then what we have is open, high, low, close values. Okay, that is what the file is. Let me try to open the file. So this is how the file is. Okay, so this is how the file, I'm closing it. I'm giving a code to open the file, to open the file and convert it into CS, the NumPy array. Okay, this code I'm already giving it here. So this is generate from text method in NumPy, which says the delimiter in the CSV column, and we say use columns from 2 to 7 only. And skip header says skip the header part, take the values from the second one. Okay, so let me coins. Okay, so this is how the data is, guys. So what we have is, so there is this open, close, high, low data, and this 1 to 28 for this last column, 1 to 28 for the first cryptocurrency, 1 to 28 for second cryptocurrency, 1 to 28 for third cryptocurrency, and the fourth cryptocurrency. Okay, this is how the data we have. You can run it, and I have given some examples of the questions. You can try it out. Last part. Thank you very much, everyone, for being having a great. Bye. Take care.
Acadgild. Average is dead.